Welcome to VR Simulation in Game Development Workshop. We're very glad you could join us. Again, thank you for joining us, and we will start the introduction bit first.
So Project Tech Conferences, or PTC, is a completely student-run nonprofit organization that plans events such as conferences, outreach events, and workshops around technological topics. We started in May 2019 in Ottawa, Ontario, and later expanded to Kingston, Waterloo, Toronto, and Vancouver. Currently, we're working on bringing PTC to different cities across Canada.
Our mission here at PTC is, of course, to provide opportunities for students to learn about technology. Through our events, such as these workshops, we strive to inspire and empower the next generation of programmers by equipping them with insight from leading professors, industry leaders, and experienced students, as well as creating opportunities to broaden their networks.
Yeah, now that everybody is here, let us get started by introducing our workshop director, William. William is a software engineering at the University of Waterloo, and he is currently an intern at Spatial, a leading startup in the field of remote collaboration in augmented and virtual reality. He is adept in a variety of languages like Java, Python, and C++, just to name a few. He channels his incredible talents toward his passion for software engineering. For example, a motion tracking and graphing app that he has developed, a drone that can survey an area for heat map data, and several first robots. On top of that, William is an avid Unity developer who uses the software to create games and VR simulations, like we're going to do today. Additionally, his CPR simulations, which he had developed at the 4th hackathon event at the University of Toronto, ranked in the top 10 out of 80 teams. So without further ado, let us welcome William.
All right. Hello, everyone. Thank you for that very nice introduction. So as you can see here, I'm in the middle of creating a project because I didn't know that you guys would have already done that already. So I take it that mostly everyone here has finished part 1, steps 1 to 4. If you have it, you can just run through it. The doc that I've sent to you guys is mostly self-sufficient on its own. So even if I'm not presenting, you can still work through most of it. But like this presentation is here to kind of like give like a visual look on how to do these steps. As well, you can also ask questions in the Zoom chat, and I'll probably see them. If we happen to have spare time, like people can perhaps even share their screens, and I can like help figure out things that are potentially a little bit difficult. So that's what's really helpful about this workshop here. All right, so still waiting on it loading. I'm going to give a bit of an overview of what we'll be creating. So this workshop has mainly 2 parts to it. The first part is the Unity part, and the second part is the AR in Unity part. So the Unity part, we'll be learning like the basics of Unity. I based the majority of this tutorial off the rollerball tutorial. That was actually the first tutorial I did when I started Unity. And it's really great because it starts from scratch. You don't need to import any assets or anything. So like you also don't need to worry about figuring out like these random things. You don't need to import a framework or like any of that. So it's really awesome. I'm skipping over parts of it, so I do recommend you still check out the entire tutorial. They talk to you about stuff like documentation, more of the stuff related to the physics system, and like UI. So those are all really helpful. Unity also has a ton of resources for you to learn, so I recommend going through some of them as well. The second half is about creating a simple AR app in Unity. So by the end of this, we'll actually adapt the rollerball game that we created in part 1 into like this kind of a game where you can pull a ball around and like collect cubes with it. This is a video of it. So you can see here, I'm kind of like dragging the ball around. So this is something really cool that you can show to your friends and family. You can have like the cubes and the ball in real space and pull it around with the camera. That's really awesome. Anyways, so actually I'm just gonna give a bit of a tour of Unity. I won't be able to show you on the screen because that thing is still loading. But essentially there's like a few main windows that you see at the beginning. The scene window is, let me just go on the screenshot right here. The scene window here shows you all the stuff related to the scene. So there's stuff like gizmos that you can use to interact with objects in the scene, and like you kind of move your camera using the WASD controls. There's the game view, which is what you would see when you're actually playing the game. This allows you to like set the resolution of the screen and see how like it works with the UI and such. So that's really helpful. There's the hierarchy panel, which allows you. Oh, maybe you're done. Oh, it's not done yet. There's the hierarchy panel, which shows you all the game objects in the scene and allows you to like reorganize them, set things as children, create new game objects and such. The project panel is kind of like Windows Explorer or Finder for your project. The inspector panel is for like configuring all your game objects and such. It's one of the more you're gonna use the inspector panel a lot to like add components and like check settings and manipulate values. Then there's the top bar and the bottom bar. The bottom bar provides some status updates with like logs you'll see in the console. And then the top bar provides you like the file edit assets and some like icons that you can use to like change your view in the scene, play, pause, step, and some other configuration settings. So this is Unity. As you can see from before, there's the scene panel, the game panel, the hierarchy, the project, the inspector, and the top and bottom bars. So let's get started. So first, we want to create a play field for our game. So we're going to create, so I right clicked here, we're going to create a plane. All right. This plane appears like this. And now we're going to rename it to So when you create game objects in a scene, sometimes they don't actually appear in the center. They'll like appear off into the distance or something. So this is why we need to reset the transform of the game object sometimes. So to reset it, you go over here in the inspector, and then you click reset. All right, so now it's at the origin. We're going to want to make sure it's in view, because sometimes you might be like looking over here to the side, and you're like, oh, where's the object? So here you go into the scene, and you press F. You can also go to edit and frame selected, and that will bring it into the view like this. So now that you have this ground in the view, we've created the ground. We're going to make it slightly bigger because this is kind of small. So we're going to change the transform, which allows us to set the scale. So set X and Z both to 2. If you were to set the Y magnitude of the scale, it wouldn't really do anything because planes are totally flat. They have no volume. Sometimes actually the Y component of the scale actually does matter, because if you're like underneath, you can't see it. But if I do make a negative, then you'll be able to see it from underneath. And then I won't be able to see it from above. So if you can't see it, make sure that this is positive and you're looking at it from above. All right, so now let's create our player. We're going to do the same thing again that we did to create the plane, but this time we're going to click on sphere. Oh, I almost forgot. We need to move the ground down a bit so that it doesn't conflict with new game objects that we create. Set the Y position to -0.5. All right. So now, as you can see, the sphere did not spawn at the center. So this is why we need to reset the transform. Now it's back. So if you look at it in the game view, you can see that the player automatically casts the shadow. So this is because every scene comes with a main camera and a directional light. If we don't have the directional light, then we don't get the lighting, the default lighting that comes with the scene. So if I disable it, everything turns black. Additionally, if we don't have the main camera, we can't see anything in the game because there's no camera. So I turn this off, then the game view will turn to black. All right. So everything that comes in is kind of like this weird, like metallic kind of gray. We want to make it look a little nicer, like add some color, right? So because these are 3D objects, they have mesh renderers. So we need to add a material to it. It's not just like a pure, like you can't just go to the sphere and edit the color. So we can do this with materials, and now we're going to create a folder to hold these materials. Go to create folder, and now name this folder materials. All right, so now we head into materials, and we do the same thing again, create, and now you go down to material. And name this material plane. Oh, it's simple. Okay. So this material is the default like material. So right now, if we were to put it on the player, it wouldn't actually change anything. Oh, we forgot. Let's rename the sphere into player. All right. So to change the color, we go to this albedo property here. We click on the color palette, and that brings up this palette. You can kind of drag this around to change the color, but we're going to actually use the RGB values of 255, 0, 255 to give us this nice like magenta color. All right, now to apply this material, we need to just drag it onto the player. And now you can see that it has the player material, and it's like this color. All right, so we've got our player. It's distinct from the ground now that we've added a material to it. Now we're gonna move our camera up so we get a better angle of the player. Because right now, like, it's kind of hard to see stuff, right? Especially if you've got a lot of stuff in a line, you won't be able to see it. So to do this, we can just move the camera around. If you notice here in the scene view, I'm scrolling with my mouse to zoom in and out. In the scene view, you can use the gizmo to move it around, in addition to setting values here in the transform. Now, obviously, if you use these gizmos, it's not the most accurate, like you can see these decimal values. So usually you want to use the inspector to fine tune them. So we're going to set the Y position to 10, the Z position to -8, and then the X rotation to 60 degrees. I'm actually not using my mouse to go through these. You can tab through the transform, which is really helpful. All right, this camera's in a nice place. If you see the star here by the scene, and also the star up here, it means your scene hasn't been saved. So we're going to press Control S or Command S to save the scene. You can also do this through File Save. Oh, I need the intros. All right, saving might take a while. But in any case, we've set up our scene. That's step 1. So now we're going to make the player move. So when we make the player move, there's usually like 2 ways we can do it. The first way is to just manipulate the transform, right? If we move the X and the Y values on the transform, we can make the player move around. But this ends up being like, you'll have to simulate your own physics if you wanted to act in accordingly to physics. But Unity provides something built in that allows you to like automatically simulate physics and add forces. So if we want to use physics, we need to add this component called the Rigidbody. So we can add a component by going to the inspector, clicking on Add Component, and then type in Rigidbody in the search, and then just click on Rigidbody. There's actually another type of rigid body called rigid body 2D. A lot of 3D things have like a 2D variant in Unity, so Unity is also usable for 2D games. Let's add the rigid body component, and now we've got it. All right, so this rigid body component has been added. Oh yeah, a small tip is you can like rearrange and collapse components. So as you can see here, that's what I did with the mesh renderer, so I could see the rigid body as well as the add component button. So now our player acts in according to physics. So actually, if we take this player and drag him up, we can see that when we play, it'll fall to the ground. If we didn't have the rigid body component, it wouldn't do that. As you can see. It is loaded. There we go, it fell to the ground. All right. Let's exit play mode, reset the player back to the ground. And now we're going to get our player under control. So this is when we need to start scripting. So a script is just another word for like a code file. So head back to the assets folder. We're going to create a new folder to hold our scripts. You know the drill, create folder, scripts. Let's import, and head into scripts, and then we can create a script by doing create C# script. So Unity uses C# to do all of its scripting. C# is like kind of like Microsoft's version of Java. So if you know Java already, you'll have a really good time with C#. So create the C# script and name it player controller. All right, now double click on the script to open. And hopefully if you've installed Unity correctly, then it should automatically open Visual Studio. You can actually use different coding IDEs with Unity. Another popular one to use is Visual Studio Code. That's actually what I use at work, and it allows you to like import a bunch of packages. And it's also more lightweight than Visual Studio, so it's pretty awesome. Anyways, open Visual Studio. I think it tries to force you to use an account, but if you don't have a Microsoft account, you should be able to still use Visual Studio to edit. In order for the script to actually do anything, we're going to need it to be on the player. So to do that, you just need to drag the script onto the player or into the player's inspector panel. Okay, so you can also add scripts directly to game objects by doing add component new script. So this creates a script and adds the script at the same time, which is really awesome. So you'll see here that this class here inherits from what is called a mono behavior. A mono behavior provides a lot of lifecycle methods on Unity game objects, as well as it also allows the script to be attached to the game object in the first place. So here we have start and update. As you see from the comments, start is called before the first frame update, and update is called once per frame. Start is actually called when the game object is activated for the first time, I believe. Or it might be every time the game object is enabled. Yes, there's actually a separate function called onEnable, which runs every time the game object is enabled. So start is run for the first time it's enabled in the scene. If you want it to run while the object is disabled, you have another function called awake. So anyways, we're not going to need update, so you can remove that, but we will need start later. So update runs every frame, but since we're doing physics, we want to use something called fixed update, which runs a fixed number of times per second. specifically, it runs 50 times per second. So create this function fix update, type in void fix update, and add braces. All right. So now let's get the input. So input comes from this class called input. You can actually search that up on Unity documentation. So that's what the other tutorial will help take you through. But for now, we'll be using input.getAccess. So type in float horizontal equals input.getAccess. So getAccess actually gets the axis of movement from the input management system. So the input management system specifies a bunch of like axes. So there's like horizontal, which is like W, A, and D, as well as the left and right arrow keys. And then there's vertical movement, which is like WS, and the up and down arrow keys. And there's also like fire and like return and escape and such like that. Well, those aren't actually axes, but they are inputs. So we're going to use the axis horizontal for the horizontal axis and vertical for the vertical axis. All right, so these specify our horizontal and vertical. In fact, at this point, we could log these values into the Unity editor. And when we press play, we'll be able to see these values. You can log things by doing debug.log. And then we can log like move horizontal, which is great. So Unity does all of this logging through debug.log. So there's also debug.warn, log warning, debug.log error. So these are different kinds of logs. Logging is very important. So it's like similar to like print line and console.log in other languages. All right. So now we want to take these horizontal and vertical values and apply it to the rigid body force. But we need a reference to the rigid body first. Oh wait, someone's asking a question. Someone has asked, how do you make a new assets folder? So normally the assets folder should come with the, like when you create the project, it should come with assets. So not sure why you didn't have one, but you can create a folder doing create folder. So that's what you can do. Right. Hold on, I need to fix something within Unity. So I'll do that first. All right, my computer has been very uncooperative with this. I'm very sorry about this. All right, it's now frozen. That's a pain. All right, okay, it has been fixed. All right, I'm just gonna back to what we had before. All right, let's continue. So to do this, we need to apply forces toward the rigid body. We need to get a reference to it. So in order to do that, there's a specific method that's provided by Gnomo behavior called get component, which allows you to get a component on a game object. Now we don't want to get the component of the rigid body every frame because that's inefficient. So we can do that by caching a reference. So create a private variable rigid body called RB at the top, class level, and then in start, which only runs once, we can do RB is equal to get component rigid body and get the rigid body. Then after that, now to fixed update, we can apply a force. Now the add force function takes something that's called a vector 3. So if you just think about vector 3, a vector 3 is just an object that holds 3 numbers, an x, a y, and a z component. It's a vector. If you know about math, you can know what vectors are, but very simply, it's just something that holds 3 numbers. So we're going to put some kind of vector 3 in here. We don't have that vector 3 yet, but we need to make it. So to do that, we're going to create a new vector after we've gotten the inputs. So we're going to call this vector 3, and we're going to create a new vector 3 using our values move horizontal and move vertical. So we want move horizontal to apply to x. We don't want to apply move vertical to y because that moves it up and down like relative to the plane. We want to move it like forward and backwards. So we're going to put 0 here. You need to put 0.0f because that specifies it's a float. Otherwise, you'll get an error because 0.0 is a double. They're both decimal numbers, but slightly different. So you'll just have to put that f. And then you put move vertical. Now we can put movement on add force. All right. Let's save. And then return to Unity. Oh, is the font a little too small? Okay, let me try to make the font bigger. There we go. How's this? Is this better? All right. I'm going to, I don't know how to leave it on screen for a little longer, but we'll come back to the script. Let's go back to Unity. And also, you can also see the final version of the script on the doc guide. All right, so every time you've edited a script, the Unity needs to kind of recompile everything, so it ends up taking a while. So now that we've attached the script to the player, we can press play to enter play mode. And now when we go on the scene and press WASD, we can move the player. All right. So currently, it feels a little bit slow. So we're going to want to make it move faster. So to do that, we can just go in here and multiply our movement by an amount, say like 10. But every time we'll have to save the script, recompile, and go back to Unity. So the inspector actually allows us to modify values on the fly, which is really helpful. So at the class level, if we want to make it accessible in the inspector, we're going to do something, we're going to make a variable public. So create a public float speed, and then now multiply the movement by the speed. Additionally, if you wanted to set like a default value for the speed when you first open the script up, you can do equals to 100%. This is just helpful if someone presses play and then they didn't set a value and it's 0, and then you get problems. So default values are pretty helpful. Save the script and go back to 80 again. Wait for it to recompile. And now if we go to the player, we can see the speed as well as the default value. You'll see in the doc that like you can edit things on the fly like this. So if I change it to 10, it'll now be 10, and it will move at like a speed of 10, which is a bit actually hard to quantify. So then you can like play, you can even edit during play mode, and if you edit these values during play mode, they don't get saved when you exit play mode. I'm just going to leave it at 10 for now, and we can see that it moves a bit faster. This is just to save a bit of time. All right, now let's work on creating collectibles. So we're going to create a new cube and name it pickup. Notice that again, it hasn't been created at 0, so we're going to reset its transform. And now it's in the way of the player. And if we do stuff with it, the player is going to be like messing with how we see it. So we'll want to disable the player now, so we can look at the pickup itself. All right, so let's make this pickup look more like a collectible. So we're going to reduce its scale to make it a bit smaller, and we're going to rotate it. Now we want to make it spin. So we're going to create a new script that will make it rotate. So a new script and name it rotator. And then click create and add. All right, and it should create the script and attach it to the pickup. When you do it through this add component way, it creates it at your root assets folder level. So you do need to drag it into the scripts folder after you've made it. All right, so we've got the rotator. The project panel actually has a secondary view. If you go to the 3 dots on the top right, there's a 1 column layout, which makes it a lot easier to do these kind of things. All right, now let's open the rotator script. If Unity will let me. I think Visual Studio also lets you access scripts from the Solution Explorer, which is pretty helpful. All right, so we've got this rotator. We're not going to need start, so you can delete it. But we are going to need update. So what we're going to do is we're going to rotate the cube with its transform. So since we're using its transform, we're not applying any physics, so we don't need to do that in fixed upgrade. Now do transform dot rotate. So one of the key, kind of like a key thing in Unity is that we don't want to modify the transform's rotation. We want to rotate the transform. And the reason this is the case is because the transform's rotation doesn't use a vector 3. So it ends up being not as intuitive as you think it is to modify the rotation. But transform does provide a rotate function. So this is what we use to move it. Here we can directly create a vector 3 in here and give it component values of 15, 30, 45. These are just random values that I picked that kind of work well. Now, if we were to just do it like this, update calls ideally like 60 times a second. So this would be rotating at an insane rate. So we need to scale this down by our time. So how do we do that? Time actually provides a neat field called delta time, which is the amount of time that has passed since the last frame. So essentially what this means is now we're basically saying that the transform rotates at 15 degrees on the x-axis per second, 30 degrees on the y-axis per second, and 45 degrees on the z-axis per second. Let's save that script and then go back to Unity. All right. So now this player, this pickup game object has the rotator script attached to it. Sometimes the inspector takes a while to load. If you were to press play, you would see the pickup object spin, which is really nice. Try it. Try it out. Let's see if it spins properly. Make sure it does. So once we've created this pickup, now we want to put them around our play area. So to do that, we need to make the pickup into a prefab. So now we're going to create a new folder at our assets level, call it prefabs. And to make a game object into a prefab, all you need to do is drag it into the folder. What a prefab does is it basically acts as like a blueprint for the game object. So instead of copying and pasting the pickup game objects around, you can actually just drag the prefab into the scene. So you can just drag this in, drag this in, drag this in. But you can also just duplicate the game object that has been a prefab. And now if you ever make changes to the prefab itself, it applies those changes to all the game objects that are copies of the prefab. All right, so you can duplicate it using Control D or Command D if you're on Mac. And this creates another one. Now, make sure you have this setting set to global if you want to be able to drag it around. If you set it to local, you won't be able to drag it around like flat relative to the ground. So let's bring it back. I don't know why it vanished itself into the board. All right, so now you can drag it around with global. So now we're going to spread these around the game area. You can put however many you'd like. I'm actually just going to put like 6. And there it is, 6 pickups. You can put 12, you can put 18, but however many you like. I put it around in a circle. You can actually like make whatever pattern you want, like an X. Actually, I wouldn't recommend putting anything in the center because that's where the player will be, but you can put them everywhere else. All right. So you'll see that all these copies, they're all at like the root level. It ends up clogging up your hierarchy a bit. So you can organize them by setting them as the children of another game object. So we're going to create a game object and name it pickup container. Make sure the transform is reset. If it's not reset and you set things as a child, that actually causes a lot of problems. So make sure it's always reset. And once it's been reset, you can just shift click all of them and drag them into the pickup container. And there it is, they're in the pickup container. Now finally, let's add some color. So you know the drill. We're going to create a material. So go to material and create material and name it pickup. And give it a yellow color. So we're going to give the color yellow, make it yellow. You can do this by just kind of like going here and configuring it. We're going to use 255, 255.0 for our RGB values. And this is our yellow pickup. Now, if you want to apply this material to all the objects, you can just drag them one by one. But we have a prefab. So we can drag this material onto the prefab. And this will apply the yellow to all the game objects. All the pickups in the scene. And look, now they're all yellow. Make sure now you can hit play and see that if they rotate, which is really nice. All right, so if we enable the player and press play, we still can't pick up these pickups yet, even though they're named pickup. We need to make a script for that to happen. So actually leave the player and re-enabled again. So enable the player again, make sure you hit this checkbox. And now we're going to attach a script onto the player. Or actually, we're going to use the player controller script to detect when the player hits the pickups and disable the pickups when it hits. So when the player hits the pickup, we can just disable it. Like our logic's kind of be like this. The player goes into the pickup, and then when it touches the pickup gets disabled, and then we've collected the pickup. All right, so now go in back to the script editor and go to the player controller. Now, modal behavior provides yet again another lifecycle method called onTriggerEnter. So onTriggerEnter gets run whenever the collider enters a trigger collider. So the collider that this script is attached to enters another trigger collider. And we get a reference to it on onTriggerEnter. The other object. Now, game objects themselves do provide some functions as well. One of which we'll be using is called compare tag. So we want to tag all the pickup objects with a pickup tag. And then if the other game object has the pickup tag, then we can disable the other game object. So these two functions, compare tag allows to compare tag, and set active allows us to enable or disable a game object. So first we want to check if the other game object, so you can access the game object through other.gameObject, and we want to see if its tag is pickup. If it is, we want to disable it. So to disable it, we set active to false. All right. Alternatively, you can also just destroy it. Both will visibly have the same effect, but this just disables it, so it can be re-enabled again. This completely destroys it and removes references to it. So this, if you ever want the game object back, you'll have to recreate it again, create it again, and that might be a little expensive. All right, so now save this script. And go back to Unity. Make sure there are no errors. All right, sweet. There are no errors. All right, you can check the console. These errors have nothing to do with the scripts. So you can see if an error actually has something to do with if it's a compile error, like pressing clear. If they disappear, they're not compile errors, and you're okay. If they're still there, then you need to fix it. All right. So if we press play now, we still won't be able to collect the pickups because we need to add the tag to the pickup. So to add a tag, you can go to the prefab, click on untag, and we don't have pickup here. So we'll need to add a tag. And when we click on add a tag, it opens the tags and layers window. Here we don't have any tags. Although you saw tags earlier when clicking on the game object, those are built-in tags. So this is our customs tags list. So we're going to click on the plus and name our new tag pickup. Let's see. Now we can edit the prefab. Click on untag, click on pickup, and since we edited the prefab, all the pickups in the scene will have the pickup tag as well. All right. So, but still, we still can't pick up the pickups. There's still one last step we have to do. And that is, these pickups are not trigger colliders. which means if we were to press play and run our player into them, we would bounce off of them. If you press play and try that, that's what you'll see. So to turn colliders into trigger colliders, there's a checkbox called is trigger. So when you turn it to a trigger, basically what you're telling Unity is that you don't want Unity to calculate a collision between this game object and another game object. And you want to allow you notify the game object that a trigger has happened, but you don't want game objects to not overlap. So Unity prevents colliders from overlapping if they're both not triggers. So to set it as a trigger, we just select the prefab again, check is trigger. That will change all the pickups in the scene into trigger colliders. And now it should work. So if you were to press play, you can go collide into all the pickups. Let's press play, see this happen. And we're collecting the pickups. Look at that. Awesome. So one last optimization issue we have here. The way Unity deals with collisions in physics is it separates colliders into dynamic colliders and static colliders. So in essence, a dynamic collider is one that has a rigid body. So Unity knows that a dynamic collider is moving. A static collider, Unity expects to not be moving. If it is moving, Unity, every time a static collider moves, Unity recaches all the static colliders in the scene. So this can end up being costly if you have a lot of colliders. So, and since we're moving the pickup by manipulating its transform, every time we move it, it has to get recompiled. So to prevent this, we're going to turn our pickup into a dynamic collider. So we need to add a rigid body. Add a rigid body component. And we know that since now it's using gravity, all these pickups are just going to fall through the floor. So we could uncheck use gravity, but we can also check is kinematic, which is basically we're telling Unity that we're going to control its transform directly. We're going to use kinematics, not dynamics, like physics and stuff. So if we check is kinematic, then the pickups will stay in place, and now they're dynamic colliders, and you can collect those, and everything is the same as before, but more optimized. Save and play, and that's the end of part 1. We've created a simple game where you can go around and collect pickups. All right, how is everybody doing right now? Are we following along okay, or are there some questions or things we're not sure about? Good, all right, awesome. Okay, so now we're gonna go on to part 3, which is building the AR app. Hopefully you guys have installed the packages already, but I'm gonna go through this because I haven't installed the packages already. So we're gonna go on Window, Package Manager. This will open up the package manager, which will allow you to install some packages. Oh, there it is. There, we just need to wait for packages to load. All right. Oh, there they are. Okay. So we have a few packages we want to install. So I'm on a Windows computer. So Windows computers can only, some people would like to see the scripts. Okay, I'm actually going to put up the scripts in just a second, but let's get these packages installing first. So then, because this might take a while. So I'm on a Windows computer, and Windows computers can only build Android apps. So to build Android apps, we're going to need what's called AR Foundation, as well as the AR Core XR plugin. So to install a package, you just select the package here, and then click install. All right, this might take a while. So here's the script again. This is player controller. And this is rotator. Oh, there's frozen. You can also find the final scripts on the doc. They're at the very end of part 2. I would love to show you what's past here and past here, but my Visual Studio is frozen. Okay, well, I'm back now. So here's the player controller script again, and the rotator script. All right, so on a Mac, you'll want to go to Window, Package Manager, and here you'll want to install the AR Foundation and the ARKit plugins. So ARKit is for iOS, AR Core is for Android. Actually, if you're on a Mac, you can also deploy to an Android phone. You have that. So you'll need AR Core for Android and ARKit for iOS. All right. Now we'll need to configure the player settings. So to configure the player settings, head to Edit, Project Settings, and click on Player. So if you're dealing with iOS, you'll want to go to the Other Settings tab. And, actually, first you'll want to enable XR Plugin Management. So go to XR Plugin Management and check ARKit if you're on iOS, check AR Core if you're on Android. Now you go to Player, and on iOS you go to Other Settings, then you need to go to the Configuration Settings, which are over here. You need to type something into camera user's description. I'm pretty sure it actually doesn't really matter what you type in, so just type in, I typed in using camera for AR. Then you'll need to go down to target minimum iOS version and set this to 11.0. Finally, go down to architecture and select ARM64. Basically, these settings allow you to build an AR app. They're the minimum requirements. On Android, you'll want to go to Other Settings. You might see Vulkan here in Graphics APIs. Make sure you remove that. That's not supported by AR Core. Then you need to go down to the Identification section and select Android 7.0 NuGet. That's the minimum version for AR Core needed. And that's it for Android. So once you've got these settings, you should be able to build the project as an AR app. But we still haven't set up the game for AR. So to do that, in the hierarchy, we'll want to create the basic AR stuff. So first, delete the main camera, because we want to set up our own AR camera. You might see main camera up here, delete that. So to delete something, right click, delete. Then we want to create the AR scene hierarchy. So since we've installed the packages, now you can go down to XR. So create an AR session. This creates the AR session and create an AR session origin. This creates an AR camera. All right, now this AR camera is not the main camera, so we need to make it the main camera. Add the tag main camera to the AR camera. All right. So save the scene periodically. Now, here's something that might be a little bit inconvenient is if we were to build this app now, we would have these objects would be huge. In Unity, roughly 1 unit is 1 meter. So this player, or this ground is like 2 meters, a lot more than 2 meters actually, because it's a plane. But like this player object is 1 by 1 by 1. So that's like 1 meter by 1 meter by 1 meter, which is huge. Additionally, these pickups are all half a meter large. So if we were to run this game, like it would be hard to do anything because these objects would be huge. But luckily we can scale things down with the AR session origin. So if we scale up the AR session origin, it makes everything else smaller. So set the scale to 4, 4, 4. Additionally, we can move it back a bit. So set the Z to -4. And make sure the rotation is 0, 0, 0. Now we don't want to see the ground when we're in AR mode because like it's kind of big and it'll get in the way. So we want to disable it by checking this checkbox. All right. Now since the ground is gone, everything's just gonna, the player's just gonna fall down and like you won't be able to see it anymore. So we want to configure new physics on the player. So select the player or the inspector here and make sure use gravity is unchecked. So you might see this, uncheck it. Let's also add some drag, so if we push it around, it doesn't like fly off into nowhere and make it hard for us to move. So set that to 0.5. At this point, you can save and play and make sure that you can still play it as normal, like with WASD. Yeah. Wait, my script is different. Oh, I'm sorry, the script is different. It's not what we had before. Let me get onto the original script. What did we have before? We didn't have any of this. And void fixed update. Float, move horizontal. Input that get axis. Horizontal. And vertical. I don't want an explosion force. Okay, so that's what we had before. I just turned the movement vector and put it straight into the Rigidbody. So now, if we press play and run it, it should play as normal. All right, now press WASD and I move it around like normal. And now that we just don't have a ground. All right. So if you were to build and run this game, all you could do is really look around. Like you can move your phone to control the position of the camera, but you can't move the player because you don't have the horizontal and vertical axes on a phone. You only have touch. So now we're going to want to move the player with touch input. We're going to want to modify the player controller. And now, originally we used fixed update, but there's something tricky about touches that makes it a bit not ideal to use in fixed update. So we're going to actually change this to update. Now, whenever we touch, how we're going to make the player move is we're going to basically pull the player towards our camera, right? So to calculate the vector that we need to pull the player towards the camera, we're just going to take the difference between the camera's position and the player's position. So to do that, we can do camera dot main dot transform. So camera dot main gives us a reference to the camera that's tagged main camera, the game object that's tagged main camera. So camera dot main dot transform dot position minus transform, which is the player's position. And we want to normalize this because that would make it so that no matter how far the player is, we always apply the same kind of force. Normalize basically means the vector has a magnitude of 1. Then we can just do RB dot add force, movement times speed. But this isn't exactly what we want because that means we're gonna apply a force on the rigid body every update, which is every frame. But we only want to do it when we tap. So to do this, we can do if input dot touch count, which is the number of touches, is greater than 0, and the first touch is in the beginning phase, then we add the force. Oh, the first touch is phase. So input provides us touch count. We want to first check that there's more than 0 touches, because if we don't do that, then we get a null reference exception when we get the first touch, because the first touch won't exist if there's no touches. Then we get the first touch, check its phase, and make sure it's at the beginning phase. That's in essence what this is doing. All right, so if we run this, it'll work pretty well, but there's actually one more optimization we can do. Camera.main is very expensive to use. Like it takes a lot of time to run. So in a similar way to the rigid body, we can cache it. So we'll want to do private camera main camera, and we can just set the main camera to camera.main and start. And then instead of using camera.main, you can use main camera. And this makes it more optimized. All right. So now if we save and we head back to Unity, and we press play, it actually won't work because clicking doesn't count as a touch. If you want to simulate touches on a computer, you'll need this app called Unity Remote 5, which you can get and set it up, but that's another thing to set up, so I won't be doing that in this workshop. So now we'll want to build and run it as an app. So to build it, go to File, Build Settings. Make sure you've added the open scenes, so add sample scene. Also make sure you saved your scene. And then on iOS, you go to the iOS platform tab and you click on Build. Then you'll go to Xcode, and there's quite a few steps you actually have to do in Xcode. So I'm going to bring up Xcode. But while we're doing that, I'm going to show how to do Android. So to go to Android, this Unity symbol indicates that I'm currently on the iOS platform. So if I'm trying to build Android and I'm on iOS, I'll need to switch platforms. First, you click Switch Platform. Make sure you have your Android device connected. And then once we switch platform, the Unity symbol is now on Android. Then to run it on your device, you just click on this drop down, select your device. Oh, I need to wait for this to finish. In essence, you would select your device and then click build and run. Make sure there are no compile errors. We did all those settings earlier to make sure those wouldn't appear. If there are any, just let me know. I can help fix that. And then press save. So select your device, build and run. Go to like navigate somewhere that you want to save it. Give your APK a name, just like name whatever you like, and then press save. And then that will build it. I'm actually going to cancel the build because I want to show how to do iOS now. It's not in the middle of loading. Anyways, the similar idea is on iOS. You switch platform and then you press build, but we will need to run it through Xcode. So switch the platform and press build it somewhere. And then once you've got it, I've got it here. You want to open the Xcode project. So open the Xcode project here. And now you've got to connect your iPhone. Make sure it's trusting the computer. Then select your iPhone by clicking on generic iOS device, your phone, and then make sure you select automatically manage signing. So you can go to here by going to the root project level by clicking on this. Clicking on signing and capabilities, automatically manage signing. Make sure you've got your team selected, and then hit run. And you've done it. Now you have built an AR app on iOS and or Android. All right, so that's pretty much it for the workshop. Did everyone get through all those steps okay, or are there any questions?
Okay, William, I think everybody seems to probably be good, or if they have any questions, they can ask in the chat. We have reached a little bit past 4:30. Regardless, thank you for the workshop. It was great. I think a lot of people really enjoyed it. And thank you all for attending the VR simulations and game development workshop. Now, we did promise to have a little bit of a Q&A session, as well as for William to a little bit showcase a little bit of his projects. So if you obviously are too busy and can't join, by all means, you can leave. That being said, please do, we hope to see you visit our other PTC events, and make sure to follow the PTC Ottawa page on Instagram at PTC Ottawa. Other than that, William, maybe we could like simultaneously do a quick Q&A and you just showcase some of one of your projects, if that's okay with you. Yep,
that's totally fine with me. I'm sorry for all the delays at the beginning.
No, it was completely fortuitous, not your fault at all. It's okay, it happens. Yeah, so in the chat, if you guys would like to just, obviously William's really adept in coding. He's at Waterloo. He's done many internships. You have any questions whatsoever, you really utilize the advantage. Ask some questions, and yeah, William, you can take it away, I guess.
All right, so yeah, feel free to ask questions to me in the chat. I'll try to answer them like as soon as I can. In fact, there's actually already one already. Oliver asked me how long I've been developing in Unity. So I've been developing for a pretty long time, actually. Unity was kind of one of my first like real coding experiences. When I first started, I started programming in Macromedia Flash, and that wasn't the best thing ever. So I've been programming Unity since I was around in, let's say, about 5 years ago or 6 years ago. Now, obviously, I haven't been coding in Unity all this time, so I would say overall I'd have like maybe 2.5 years of experience. So yeah, Unity has changed a lot over the past few years. So it's honestly, I really love it. One of the great things about Unity is how easy it is to learn. There's so much good documentation and tutorials everywhere, and I hope this one is also fairly good. I have noticed that AR tutorials are not that common on Unity. So yeah. All right, so currently I am on an internship at Spatial, and I'd actually love to talk a little bit about Spatial. So Spatial is kind of a virtual and augmented reality tool that turns any room into a 3D work and learning space. It's like video chat, but in 3D. Again, if you wanted to check out their website, head to spatial.io. It's pretty awesome. I'm gonna put this video in the background while I talk a little bit about it. So one of the great things about Spatial is it's like really, it kind of makes you feel like you're in a 3D space with other people. So we do that with like sense of presence. We have 3D avatars. You can actually create a 3D avatar with just an image, so, just like a selfie. And on our website, it makes an avatar for you. There's a lot of learning and collaborating tools. There's like drawing, whiteboarding, creating notes. You can search for models and images in app. And you can easily share information. So like you can screen share, you can turn on your webcam if you're a web user, and you can upload lots of files. So Spatial can be kind of used in many different use cases. Some of the main use cases are 3D design and data review. So like if you're working on like a model of a car, or like if you're working on kind of maybe like you're graphing some software and you want to visualize the 3D graph in Spatial, that's what you can do. Companies like Mattel and Ford are using it. You can also use Spatial for team meetings. So in fact, at Spatial right now, we use it for stand-ups. And then you can use it for training and education. So a lot of educators and universities are looking into using Spatial to like have classrooms and stuff, which is really, really cool. Oh, Josh has asked, what am I working on right now? I am actually about to get to that, and it's pretty exciting. So just wait, hold on a sec. I just have one last little thing to say. So currently Spatial, our main experience is done through headset. So we support devices HoloLens, Magic Leap, and Oculus Quest. If you have any of those devices, I would actually love for you to I'd love to invite you to our guest Slack channel. So just email me at hello@williamkim.com. You can find it at the top of the doc. That's my email. If you have any of those devices, it'd be great to see you in headset, because I'd love for you to try it. It's currently free right now. In addition to headset, we also have web experiences for desktop and mobile users. But the web experience only allows you to like create an avatar and then spectate a room. You don't really get to participate in it. But that's what I'm working on. I'm working on creating a mobile app so that you can interact, like almost everyone that has a phone, like everyone has a phone, you can now interact in a spatial room by downloading the app. And so that's actually directly related to what we did in Unity today, which was build an AR app. That's kind of how we're building the AR app in Spatial as well. We're using the AR Core, AR Kit, and AR Foundation plugins, and then we're doing like build and run and such. So that's really exciting. I would actually like to give you guys a sneak preview of what I'm working on. So this is the mobile app. Here's a short video that I took of it. Oh, it's loading. All right, I'm going to pull it up on. Oh wait, it's currently my Mac that is sharing screen. That's why you guys can't see the video. All right, I'm gonna get the video out for you guys. In any case, Jenna asked, which programs did you attend in high school that helped you develop your skills? Oh, okay. I mean, obviously I did Unity tutorials, which is really amazing. But yeah, a lot of my formative experiences in high school in terms of programming, I learned from going to hackathons and just like actually doing the work. It gives you that kind of push to make something that works, work with other people, and you can learn from them, which is really amazing. My CPR VR was created at U of T Hacks, and it got top 10, which is really awesome. And it was a pretty neat project. It actually helped me get my current internship right now, which is pretty awesome. So here, let me pull out the video. So yeah, I definitely recommend doing hackathons. That is the number one. Although right now it's kind of like just quarantine and going to conferences is very not a good idea. So as an alternative, there are a lot of virtual hackathons. So just kind of like build a project, work on it, make it happen. That is honestly what made me who I am today. Another program that's also great is First Robotics. That's what I attended. It taught me a lot about Java and like motion control and stuff. And it was a whole lot of fun. I don't know. It taught me a lot about like computer vision as well, so it got me into that field. So yeah, overall those two things. Okay, let me pull up the video. This is a sneak preview of what I'm working on right now. So here's the mobile app. All right. You can see here, there's like this kind of like intro screen. I built most of the UI using React Native, and then the Unity, it shows like a Unity view. So this is Unity, and this uses like AR and stuff. So we built it in very much the same way that we did in the tutorial. So yeah, stay tuned for the mobile app. It's coming out fairly soon. All right, Ollie asked, what is the best place to go for learning VR? All right, so when you're talking about VR, honestly, when I first started with VR, I just kind of searched up tutorials and stuff. I believe Unity does have tutorials for VR right now. In fact, Unity is offering a few months of Unity Premium for learning, so you can go there and learn about VR. You can also just find a lot of like getting started tutorials, right? So if you have like an Oculus headset, Oculus provides some tutorials on how to build Unity VR apps. If you want to do Google Cardboard, you can go to like Google's website and they have like getting started with like Google Cardboard. So yeah, those like getting started tutorials are amazing. They always get you, they're always really helpful and kind of teach you the fundamentals of dealing with the kind of hardware they're working with. So yeah, this is a sneak preview of the mobile app. It's pretty exciting. In fact, actually, if you'd like to get access to mobile app when we first release it to beta testing, send me an email and I'll invite you to the guest Slack channel. And then you'll get updates there when the mobile app first launches. All right, that's pretty much what I have to show about spatial. Are there any other questions? Ooh, okay. Sorry if I mispronounced your name. Arco asked, is Unity flexible or functional enough for what you do? Is it common that companies move away from Unity and start using their own customized renderers / game engines? I think nowadays game engines are getting really solid. They actually work really well. Unity has a lot of built-in stuff, but the built-in stuff doesn't work that well. So what most companies end up doing is they start writing their custom like shaders and scripts and stuff within Unity. So Unity provides a ton of flexibility in terms of like designing your own stuff. So that's really great. So I find that personally for our company, we have not pivoted away from Unity at all. Building a game engine is actually extremely costly and doesn't provide a ton of like benefits compared to just using the built-in like Unity game engine. So we still use Unity a lot. We're like heavily Unity developers, and I don't see that changing anytime soon. So yeah, it is very flexible and functional.
Yeah, if that's all the questions, thank you, William, again for running this amazing workshop today. Unfortunately, the time is up for us to wrap up, but thank you everybody for attending our VR workshop today. We hope you all were able to learn something new today. If you have any questions for William, yeah, you can leave them in the chat, but I think...
Oh yeah, you feel free to email me.
Yeah.
let's respond.
Yeah, maybe you could leave that in the chat.
Yeah, and so the doc that I've linked is very comprehensive. So, I mean, if you ever get stuck on any step, please do email me, because that way we can update it and make sure everyone has a working document.
Yeah. So if that's the case, then thank you again for everybody to attend, and thank you, William. We hope to see everybody at future PTC events, and also make sure to follow our Instagram page at PTC Ottawa so that you stay up to date with all of our events. Stay safe, and we hope to see you soon.